Look up at the night sky. A dark canvas scattered with points of light. Most are stars, but some are entire galaxies, each a city of billions of stars. Today we journey to one of the most peculiar galaxies ever found. It lies 600 million light-years away in the constellation Serpens Caput. This is Hoag's object, discovered in 1950 by Arthur Hoag. At first it was mistaken for a planetary nebula, but it turned out to be something much stranger, a galaxy shaped like a perfect ring. Picture a golden sphere of old stars at the centre, surrounded by a vast empty gap. Beyond that, a brilliant blue ring of young hot stars forms a cosmic halo. This structure is what makes Hoag's object so unique. It's a riddle in the night sky, a galaxy that defies our understanding. Why does it look so different from all the others? For over 70 years, astronomers have puzzled over its perfect symmetry and mysterious formation. The more we study Hoag's object, the more questions arise. It's a reminder that the universe is full of surprises and that our knowledge is far from complete. Hoag's object stands as a cosmic jewel, a smoke ring in space. What forces could have sculpted such a perfect and unusual shape? Join me as we explore this mystery. Let's journey into the heart of a galaxy that challenges everything we know. The adventure begins now. To see why Hoag's object is so strange, let's look at what's normal. Most galaxies are spirals, like the Milky Way, with bright centres and swirling arms. Others are elliptical, giant smooth balls of old stars. Some are irregular, chaotic shapes born from cosmic collisions. These three types, spiral, elliptical and irregular, make up nearly all known galaxies. But Hoag's object fits none of these categories. It has no spiral arms, so it's not a spiral. Its ring is too defined for an elliptical, and it's far too symmetrical to be irregular. Instead, it's a rare ring galaxy, the most perfect example ever found. Its core is a smooth ball of old stars, while the ring is a separate, brilliant circle of blue light. Between them lies a mysterious dark gap. This separation makes Hoag's object a cosmic question mark. It's as if two different galaxies were fused together in a way that makes no sense. Hoag's object challenges our neat classifications of the cosmos. It stands alone, defying the standard blueprints of galaxy formation. How did such a structure come to be? That's the puzzle astronomers are still trying to solve. The universe is full of patterns, gravity-shaped stars. Stars form galaxies, and galaxies follow certain rules. A galaxy's shape tells its story. Spirals are sites of ongoing creation, their arms lit by young blue stars. Elliptical galaxies are older, their stars formed long ago, often after violent mergers. When spirals collide, their structures are destroyed, leaving behind smooth, featureless balls of stars. Hoag's object, though, tells a story we can't yet read. Its core resembles an old elliptical filled with ancient yellow stars. The outer ring, by contrast, is a nursery of young, hot blue stars, like a spiral arm but detached. How can an ancient core and a youthful ring coexist, separated by a dark gap? This is the central puzzle of Hoag's object. It's as if two different eras of galactic history are frozen side by side. No other galaxy combines these features so perfectly. The shape of Hoag's object hints at a dramatic past, but the details remain hidden. Its structure is a fossil record we have yet to decipher. What could have created such a unique combination? The answer remains one of astronomy's greatest mysteries. The ring of Hoag's object is a perfect circle, larger than the Milky Way. It's packed with gas, dust and countless young blue stars, cosmic newborns. Most ring galaxies form after a smaller galaxy crashes through a larger one, creating a ripple of star formation. Imagine a stone thrown into a pond, sending out ripples. That's how most rings are made. But with Hoag's object, there's no sign of an intruder galaxy. Astronomers have searched the surrounding space and found nothing that could have caused such a ripple. This absence makes Hoag's object baffling. If not a collision, what created this isolated perfect ring? It seems to have formed without any outside help, defying our best models. It's like finding a perfect ripple in a pond with no stone in sight. The ring's isolation is as mysterious as its symmetry. No other ring galaxy is quite like it. The structure stands as a cosmic magic trick, one we can't yet explain. Hoag's object is the ultimate outlier. Its ring is both a clue and a challenge to our understanding. The mystery deepens the more we look. If a recent collision seems unlikely, maybe the event happened billions of years ago. The intruder galaxy could have moved far away, lost among countless others. This theory suggests we're seeing the aftermath of an ancient cosmic hit-and-run. The collision would have created the ring, then the intruder vanished. The core, stripped of gas, settled into a smooth, round ball of old stars. But for the ring to be so perfectly circular, the collision had to be almost exactly head-on. A rare event. Most galactic cores are flattened or bar-shaped, but Hoag's is nearly a perfect sphere. A violent impact should have disturbed the core's shape. The symmetry of both core and ring is hard to explain with a simple collision. Maybe our models of galaxy collisions are too simple. Or perhaps something else entirely is at work. The more we learn, the more improbable a straightforward collision seems. Hoag's object keeps its secrets well hidden. The search for answers continues. What if the ring formed from within, not from an outside force? One theory involves a bar instability. A bar of stars at the center of a spiral galaxy can become unstable, pushing gas outward to form a ring. Hoag's object might have once been a barred spiral, its bar dissolving and sending gas into a perfect ring, but we've never seen a bar instability create such a massive detached ring. There's no trace of a bar left in the core. Another idea, the ring is the ghost of another galaxy. A smaller, gas-rich galaxy could have been torn apart by Hoag's gravity. Its gas stretched into a ring that formed new stars. The core of the smaller galaxy might have been destroyed or swallowed. This process, called accretion, is common in galaxy growth, but the perfect symmetry of Hoag's object is still hard to explain. No other known galaxy shows such a clean, isolated ring. Each theory raises new questions. The true origin of Hoag's object remains elusive. Its formation is still a cosmic enigma. The more we study Hoag's object, the more mysteries appear. The Hubble Space Telescope found another ring galaxy, perfectly aligned in the background, a cosmic coincidence. The odds of finding two ring galaxies lined up like this are astronomical. The core and ring of Hoag's object rotate together, suggesting a shared origin. This challenges the idea that the ring is a captured remnant. The dark gap between core and ring is nearly empty, with only a few old star clusters. Why is this region so barren? Every answer leads to more questions. Hoag's object is a puzzle that refuses to be solved. What is Hoag's object? A cosmic bullseye collision, the ghost of a devoured galaxy, or something entirely new? After decades of study, it remains one of astronomy's greatest mysteries. Hoag's object reminds us how much we have yet to learn. It stands as a source of wonder, challenging our imagination and our science. Every unanswered question is an invitation to look deeper. New telescopes are searching for clues, bringing us closer to the truth. The story of Hoag's object is a journey into the unknown. The universe is waiting for us to solve its riddles.